You may have heard that fiber optic networks carry most of the global traffic. It is often said that more than 95% of all the data that moves around the world passes through undersea fiber optic cables. If we take the example of the basic internet layout used in our recent video, you will notice we have now added some pink circles. These represent the points where electrical signals are converted into optical signals and vice versa. In a typical network, as shown here, you can identify the points where optical signals are converted into Ethernet frames which are electrical in nature and vice versa. The process of optical to optical conversion gives rise to three main issues. First, latency increases due to the conversions between the optical and electrical domains. Second, there is waste of power during the conversion process. Third, the amount of data that can be transmitted is significantly reduced because Ethernet cannot carry as much data as fiber. These were the main reasons behind the creation of the All-Photonics Network or APN. These technical challenges such as latency, power inefficiency, and bandwidth limits are not just minor issues. They become more serious when scaled across today's complex network environments. To understand the issue better, let us look at this diagram showing the challenges in today's infrastructure. The current network setup faces several major limitations. Optical access networks are designed for basic broadband but cannot support demanding applications such as 5G and 6G, which require their own dedicated fiber infrastructure. This creates a bottleneck that slows the growth of mobile networks. Communication between devices and cloud data centers also suffers from significant delays, often tens of milliseconds, because of multiple network layers involved. Edge computing was introduced to reduce these delays, but it reduces the cost benefits of centralized cloud computing. Many enterprises are also hesitant to depend on a single carrier for edge infrastructure. Another challenge is power consumption. Large cloud data centers can use more than 100 megawatts, making it difficult for communities to power them entirely with renewable energy. The proposed solution introduces an interconnect core that significantly improves capacity, latency, and energy efficiency. It also enables a converged optical access system, which is shared optical infrastructure that serves multiple service levels and user types instead of requiring separate networks for each application. The key transformation is moving from fragmented, purpose-built networks to a unified, high-performance optical infrastructure that can efficiently support everything from basic broadband to advanced services such as 5G and 6G. This slide and the next one are from Fujitsu at MWC 2023. As you can see, they provide a clear explanation of the concept behind the innovative optical and wireless network or IOWN. IOWN is being standardized by the IOWN Global Forum, which includes around 150 industry-leading organizations from around the world, working together to accelerate innovation and the adoption of connective technologies. Their bold aim is to build a new kind of communication infrastructure using photonics from end to end. The IOWN Global Forum works on both the technical components and the use cases that will enable a smarter, more connected world. Its efforts go beyond defining technology. They also focus on how it will be deployed and used in real-world scenarios. This slide presents a comparison between current optical networks and the future All-Photonics Network as envisioned by IOWN. As you can see, the use of fiber end-to-end along with photonic gateways helps address the challenges we discussed earlier. This recent slide from NTT Docomo provides figures that help put things into perspective. Power consumption is significantly reduced, making power efficiency up to 100 times greater. Latency is reduced to 1/200th of its current level, and transmission capacity can be up to 125 times higher. While there are many potential use cases that could benefit from IOWN, the initial areas of focus are cyber-physical systems and AI integrated communications. These require extremely low latency, high capacity, and real-time responsiveness, which APN can help enable. The key technology that makes the All-Photonics Network possible is known as Photonics Electronics Convergence, or PEC. This technology enables seamless integration between photonic and electronic components, allowing for faster, more efficient data transmission. It was showcased at MWC this year and is no longer just a concept. It is already a working reality, demonstrating that the foundations of IOWN are actively being put into place. Finally, it is worth emphasizing that the IOWN Global Forum consistently uses the term open alongside APN to highlight the importance of openness and ecosystem collaboration as shown in the architecture diagram. This reflects the forum's commitment to open standards, interoperability, and cooperation across vendors, operators, and research organizations. As you may have noticed, the IOWN Global Forum's overall architecture includes not only the All-Photonics Network but also the data-centric infrastructure and the cognitive foundation. To deliver future digital experiences, it is essential to build a platform capable of processing large volumes of data from diverse devices and locations in a timely, efficient, flexible, and secure way. To support this, the IOWN Data Hub Task Force is developing mechanisms for data processing and management and has defined the IOWN Data Hub architecture. Here are some references and further reading materials. These slides will be available on the 3G4G homepage. See the video description for the link and details. If this topic interests you, do explore the linked papers as they provide a wealth of useful information. And that brings us to the end of this brief overview of IOWN's all-photonic network, which we believe will play a significant role in shaping the networks of the future. If you found this video useful, please consider liking, subscribing, or leaving a comment to share your thoughts. And do check the description below for further reading and links to related resources.